Now, lesson 5.5, indirect proof and inequalities in one triangle. Okay? I'm less concerned about an indirect proof and more about inequalities in one triangle. All right, theorems, angle-side relationships. If two sides of a triangle are not congruent, then the larger angle is opposite the larger side. You guys remember this? If I've got a triangle, if this angle is bigger than this one, then this side, the opposite side, is bigger. You guys remember that? Yeah. And if there is a longer side, and you know this side is longer than this side, that means the opposite angle is larger than the other angle. Do you guys remember that? Not really? Okay, so the whole idea is, you see here, you have opposite angles. So here, this angle is opposite that side, right? And this angle is opposite that side. You see that? So if this angle is bigger, then the opposite side is bigger than this one. If this angle is bigger than this one, then this side is bigger than that one. You see? And vice versa, if this side is bigger than this one, then this angle is bigger than that one. See? Angles and the sides are proportionate. Okay? Continuing on. Okay. Ordering triangle side lengths or angles. Okay? So this would be an example of a question we could get. So write the angles in order from smallest to largest. Well, this is the smallest, so that's the smallest. Then comes 15, so that's number 2. So that's 1, 2, and 3. You guys see this? This is inequalities in one triangle. Okay. Okay, you guys, so this is why you got to pay attention, because I got to go way too fast for you to just be like, what's going on? Okay? You got to pay attention, because I'm making it clear, just not listening. Okay? Look, I have 3 angles in a triangle. I also have 3 sides. If the angle corresponds to the opposite side, so if that's the smallest side, then the opposite angle, this one here, is the smallest angle. This is the middle, so that's the middle angle. That's the largest, so that's the largest angle. You see that? Right here. Okay? Does that make sense? You kind of see that? It's opposite angles correspond to their sides. Okay? So how do I know which one is opposite? Well, that angle is opposite that side, that angle is opposite that side, and that angle is opposite that side. Okay? So this is clearly the smallest side, so this is the smallest angle. Then this is the second, so that's the smallest, number 1, medium, number 2, and this is the largest side, so that's the largest angle, number 3. You see? That's what triangle inequalities are. One triangle inequality. Now, next. Okay. Triangle inequality theorem. What does this say to us? What does this say to us? Well, 2 sides of a triangle always have to be bigger than the third side. So 3 plus 5 is 8, which is bigger than 7. That's good. 3 plus 7 is 10, which is bigger than 5. That's good. 5 plus 7 is 12, which is bigger than 3. That's good. So this can be a triangle. 4 plus 6.5 is not greater than 11. It's 10.5, which is less than 11. So this cannot be a triangle. You see? You guys remember that? This is very early in the semester. Okay? So we went over this stuff. All right. Next. So it might say tell whether a triangle can have the given sides. So let's take a look at this example. So this example says 8, 13, and 21. If I do 8 plus 13, I'm trying to see if it's bigger than 21. Well, 8 plus 13 is 21. Is 21 bigger than 21? No, so that can't be a triangle. You see that? Does that make sense to you guys? Mm-hmm. Any questions on that? Okay, cool. So that's that one. Okay. Next. Okay, finding side lengths. So, what if I told you, this was another thing that we went over in class. if I give you two sides, for instance, 5 and 9, and I say, what is the possible range of the third side? How do you do it? You put side in between these two. You subtract to get the left, and what do you do to get the one on the right? Add. So this is 4 is less than S is less than 14. That's the range of possible sides. You see why I'm telling you guys you need to study? This stuff right here, it's been a while, right? I'm going over it, but I got to go over it fast because this is just one lesson. Okay, I can't just reteach every single lesson. I don't have enough time. Okay, so that's how you do it. You add and subtract. What's another example? 6 and 11. Find the range of possible sides. You subtract to get the left. You add to get the right. So it's 5 is less than S is less than 17. And you're done. Okay? And if I'm going too fast for you to take notes, that's okay. I'm recording all this and it will be on YouTube. So don't feel like you have to take notes all the time. Okay? Just pay attention. Make sure you're paying attention. Okay, so that's that lesson. All right? That's lesson 5.5. So now we go to lesson 5.6. Okay, and lesson 5.6 is two triangle inequalities. Like I said, don't feel like you've got to write every single thing down right now. You can if you want to. Okay, two triangle inequalities. What does this say? Well, what this says is, take a look. If I've got two triangles and the two sides are congruent, if this angle in red is bigger than this angle in blue, then this side in red is bigger than that side in blue. See that? So that angle is bigger, so the side is bigger. That angle is smaller, so the side is smaller. And likewise, if I've got two congruent sides and I know this side is bigger than that side, if that side's bigger, then that angle is bigger. If that side's bigger, then that angle is bigger, even in two triangles. Does that make sense to you guys? As the angle grows, the side grows. Okay, so these two sides are congruent. If that angle increases, then that side increases. Okay, they're related like that. Okay, so what's an example of a possible problem? Let's take a look at these two. It says compare the given measures. So it says compare MEGH. EGH is this one. And EGF. EGF is this one. Okay, well, look, this side is clearly congruent because it's the same. And then this side here is 12 and that's 12. So those two sides are congruent. So the question is this angle bigger or smaller than the blue one? Raise your hand if you think the blue one is the biggest. Raise your hand if you think the red one is the biggest. Why do you think the red one's the biggest? Because that's 10, you see? Since that side is bigger than that side, then the red angle is bigger than the blue angle. Cool. Now, BC and AB. Okay, so it asks us to compare BC, this side, and AB, this side. We notice that this side 9 is congruent to this side, and this side is shared, so it's obviously congruent. This angle is 65. This angle is 64. Raise your hand if you think the blue side is bigger. Raise your hand if you think the red side is bigger. Good, good. So we know that BC is bigger than AB because that angle is bigger than that one. Good. So you guys get this. Very good. Okay, that's that lesson. Now, the Pythagorean Theorem. You guys have used the Pythagorean Theorem many times before, so this should just be kind of simple for you at this point. Okay? Find the value of x. Okay? It says give your answer in simplest radical form. We're just going to do the first one here. Okay? How do I find x? What's the Pythagorean Theorem? Very good. If I have a right triangle and I have two legs. Yeah, it has it on the cheat sheet. So the key is that the The ones that are touching the right angle are the ones by together. The hypotenuse, which is opposite the right angle, is the one by itself. You see that?
Whatever's okay, thanks.
Yeah, probably not going to. Probably just have to wait for the hour. Okay. Now, how do I do that in this case? Which one is C for 1A? Which one of X is C? So 4 squared plus 8 squared equals X squared. 4 squared is 16. 8 squared is 64 equals X squared. So 80 equals X squared. Square root both sides. X equals square root of 80. Pretty sure you're going to have calculators for the test. I have to ask the lead team, for the geometry team, to make sure. But I'm pretty sure you guys are going to have calculators for this whole test. I will see what the deal is with that. But you guys got that? Does that make sense? Okay. Oh, sorry. This is no longer less than 5.6. This is now less than 5.7. So 5.7 Pythagorean theorem. She got super scared.
How could you hear that? How is that loud to hear though?
I don't know, because she was very loud. Okay.
Oh, was that Samantha?
No, it was.
Yeah.
It was.
Was it not?
No, it was Samantha. Samantha.
Hawa. Oh yeah, it was.
Can I please say hi 2 seconds? She's leaving. Please.
No.
Oh!
That was scary. Like, who?
No. It was inappropriate. Okay. Shh, 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 shh. All right. Okay. Find the missing side length. All right, so here's the side. We'll call that x. Here's the side. We'll call it x. Here, which is the hypotenuse? Which is the hypotenuse? X. Yeah. So it's 8 squared plus 10 squared equals x squared. So that one's like the other one, so we're not going to do that one. Here, which one's the hypotenuse?
26.
Good. So it's 24 squared. I hope everyone's paying attention. Plus x squared equals 26 squared. You plug it in your calculator. 24 squared is 576. Plus x squared equals 26 squared, which is 676. Okay? What do you do now? Subtract 576. You end up with x squared equals 100. Take the square root of both sides. You get x equals 10. Does that make sense? Okay. All right, so that's Pythagorean theorem. All right. Any questions on that? All right, so let's move on to chapter 6. Okay, chapter 6, 6.1. Chapter 6 is on polygons and quadrilaterals. 6.1 is just properties of polygons. So it's just on polygons. Just, Matthew, why don't you come sit right here so Priscilla can pay attention. And you can pay attention too. Yes. Okay. Chapter 6 is on polygons. Sorry. What is a polygon? It's a good question.
It's quadrilateral.
A quadrilateral is a polygon, but not all polygons are quadrilateral. The best way to think about polygons is to look at them visually. Raise your hand if you think this is a polygon. It's not, because it's open. You see? Raise your hand if you think this is a polygon. Good. Raise your hand if you think this is a polygon. No, there's a curved side. All the polygons are straight.
That's concave.
No, it's concave, yes, but it's not a polygon because it's got a curved side. Okay? And a regular polygon has all the same sides and all the same angles. Okay, so all the angles and all the sides are the same in a regular polygon. Now, concave and convex. How can you tell the difference between concave and convex? Concave, the definition is if any part of the diagonal contains points in the exterior of the polygon. Okay? Any point of the diagonal contains points in the exterior of the polygon. Alright, that's the technical definition of it. But concave, you see it caves in. Does that make sense? Convex, it doesn't cave in. Alright? Or in other words, all the diagonals are inside. Okay, remember those definitions. There will be a vocabulary section on this test, so you'll have to remember those. Okay, take a look at this. Irregular, convex. Why is it irregular? Regular means all sides and all angles are the same. Why is that one irregular? Not all sides are the same, right? Some are longer than others. B. Why is B irregular? All the sides are the same. Good. Why is C irregular? All the sides are the same, but it's got different angles. You see there's the small angles and then there's the bigger type of angle. You see that? Okay. Why is it concave? Caves in, right? And in other words, the diagonals, there are parts. If I draw a line from this vertex to this vertex, it's outside of the polygon, so it's concave. Okay? Triangle, quadrilateral, pentagon, hexagon. Look, triangle starts with 180. Every time I add another side, I add another 180, you see? Add another side. 4 sides is, what is it called? 4 sides? Quadrilateral. So add 180 is 360 degrees inside of a quadrilateral. So all the interior angles, what do the angles add up to in a triangle? What? 180. What do the angles add up to in a quadrilateral? 360, because I added a side. In a pentagon, add another side, add another 180, you see? So it's 540. Add another side, 720. How do you get the formula? It's n minus 2 times 180, where n is the number of sides. Okay? So it's n minus 2 times 180. So what about if I said, what's the sum of the interior angles in an octagon? What's n in an octagon? 8. So it'd be 8 minus 2 times 180, or 6 times 180. 6 times 180 is 1080, 1080. See? Does that make sense? Okay, so there you go. Now, what about if I asked you, okay, so you know it's 1080, but what's every angle in a regular octagon equal to? What should I do?
Irregular?
In a regular octagon. If I divide it by 8. Why would I divide it by 8?
That's the number of sides.
Because there's 8 angles or 8 sides in an octagon. So if they're all the same, then they're all equal to 135. Okay? All right. Now. What are you doing? What? Don't do that, Marcus. Okay. Now, look at this. You guys see this? You see how these are all exterior angles here? It's angles on the outside. See that? No matter what shape you have, as long as it's a convex polygon, which means it doesn't cave in, no matter what shape you have, the exterior angles always add up to 360. You see? You add all these up, it's got 5 sides, 360. No matter what, it always adds up to 360. Is that your friend? Is that Samantha? Go ahead.
Oh,
Go ahead.
I'll be right
You're
back.
welcome. You have 30 seconds. Okay. Now, what about if I have something like this? Look at this example here. It says solve for r. How would I do it? What do I know that they all add up to? You guys paying attention? What do they all add up to? 360. Very good. So 8r plus 4r plus 7r plus 5r equals 360. 8 plus 4 is 12, plus 7 is 19, plus 5 is 24. So 24r equals 360. Divide by 24. I get r equals 15. Okay? You see that? Simple as that, but you have to remember that concept. This whole final exam is going to be about remembering concepts. If you can't remember the concepts, then you're not going to be able to do it. You'll look at this and be like, I have no idea how to solve for r. Right? But that's where the studying comes in. You have to study. You have to study hard. Okay?
Thank you.
You're welcome, sir.
Oh, wait, can we go up again?
Yeah.
That kind of looks like.
Oh, we still got it.
All right. Next, parallelogram. Properties of parallelograms. 6.2. Parallelograms. Okay. Shh. Parallelograms. All right. First thing, a parallelogram is a quadrilateral, which means how many sides does it have? 4. Good. In a parallelogram, the opposite sides are congruent and the opposite sides are parallel. Okay? In the parallelogram, the opposite sides are congruent and parallel. That's what you have to remember. What does congruent mean? It's got the same what?
Size.
Same size and shape, but it's just a side, so it's just the same length. Okay? Opposite sides are congruent and parallel. Also, opposite angles of a parallelogram are congruent. So these angles are the same, those angles are the same. Also, consecutive angles, the blue and the red, they're not congruent, they're what?
Supplementary.
Supplementary. They add up to what?
180.
180. Very good. Also, if a quadrilateral is a parallelogram, then the diagonals bisect each other. What does it mean to bisect something? Cut it in half. Bi, think bicycle, think 2, think half. Right? Okay. So, that's a parallelogram. Now, here's an example. Here's a good example of a question that I could ask. Say solve for x and solve for y. Okay, if it's a parallelogram, what do I know about the opposite sides? They're what? Congruent. So I set them equal. Guys, if you don't have any idea what to do, just set them equal. Okay? If you have no idea what to do, just set them equal. 80% of the time in this class, you'll be right. Okay? I'm just being honest. Okay, so subtract 5x from both sides. You get 19 equals 2x. Divide by 2, you get 9.5. X equals 9.5. Okay? But if you understand, what was that? 7x is here. 7x equals 5x plus 19. Okay? So I solve for x. What if I wanted to solve for the sides? What would I do?
6y.
Plug it back in. Plug it back in. And I get 66.5. Okay? Now, these two angles, are they consecutive or opposite? Consecutive. They're not opposite. So are they congruent? No, they are supplementary, which means they add up to 180. So I add them together, set it equal to 180. 16y plus 4 equals 180. Subtract 4. 16y equals 176. Shh. Divide by 16. Y equals 11. Guys,
No, so someone stole my shoes.
I understand that, but Matthew, it's been all semester. I'm going to tell your teacher next semester, I'm going to be like, look, next time when Matthew comes in, make sure you give him a fraction immediately.
What if it's you?
Then I'll just tell myself that. I will.
Okay, let's go.
I don't know if it was yours.
Shh. But how do you do that?
Sorry. So I'm kind of mad.
I get it, but that doesn't take place in my classroom.
Yes, sir.
All right. Now, what about this one? EFGH. This parallelogram. How could I solve for Z and W? What do I know about them? What do I know about them? They bisect, which means they are equal. They're congruent, because this one has to equal this one, and this one has to equal this one. So I subtract 4z from both sides. I get negative 9 equals negative 2z. Divide by negative 2. Sorry. Negative 2. And I get z equals 4.5. Here I set 3w equal to w plus 8. Subtract w from both sides. I get 2w equals 8. Divide by 2. I get w equals 4. Is that pretty clear?
Is there it for that thing?
For that? Yeah, well, you could have set them. Oh, sorry. You could have plugged them back in. So if I asked you, for instance, like for JG, you'd plug w back in, you get 4 plus 8 is 12. Does that make sense?
Yeah.
Okay. So if whatever I asked you for, you just plug it back in. Okay? Good question. All right, that's it for 6.2. 6.3, last one of the day. Last one.
For real?
Yeah. This is the last one. That's good enough. Okay. Conditions for parallelograms. All right. This is basically the same deal. All right.
So we're done?
Man, I would love to get. Hold on. 6. What I got? 7, 8, 11, 12. I got 4 more chapters to
We
do.
can do that.
I got enough time for that. That's fine. Hold on. I'm not gonna go through all these. You won't remember it if I do. Okay. So. I'll get it. I'll get it. Thank you.
Does he know they're yours?
Probably not.
Because you told me to come choose.
Yeah, the Bible's not.
They're real. I'll do them back.
Yeah, he probably didn't do it on purpose. Because he likes you.
You know what I do when people steal my shoes?
It's kind of
I start not changing my socks, and then next time if they steal my shoes, they'll be like, "Oh, no way."
That's disgusting.
Okay, just wear the same socks over and over. No, we're not. Shh. Okay.
The last one though?
I can just leave my stuff around.
It's the last one though?
Okay.
No.
Look.
We're not supposed to.
Shh. 2 more example problems. Yeah. This is the last lesson. Okay. Look. Show that it's a parallelogram for a equals 2.4 and b equals 9. How do I show that? Well, what do I know about opposite sides? Sit down, please. What about opposite sides? What do I know about opposite sides?
When did I stand up?
I don't know. When you went to go into the phone. What do I know about opposite sides in parallelogram? They have to be what? Congruent. So if I plug 2.4 in for A, what should I get? Should they be the same or should they be different? The same. 7 times 2.4 is 16.8. 2 times 2.4 is 4.8 plus 12 is 16.8. Does that make sense?
Yeah.
They're the same. They're congruent. That's good. Now, what about these 2 angles? They should be supplementary. So if I plug in B, what should they all add up to? 180. Good. 10 times 9 minus 16 plus 9 times 9 plus 25 is 90 minus 16 plus 81 plus 25. Okay? 90 minus 16 is 74, plus 81 is 155, plus 25 is 180. What did I prove? That this shape is a parallelogram. Parallelogram. I showed this a parallelogram because consecutive angles are supplementary, opposite sides are congruent. What about opposite angles in a parallelogram? They are congruent. Very good. Opposite angles are congruent. Good. Next. Last example, and then you are done for the day. Let's take a look.
Oh, it looks like a cake. That looks like a wedding cake.
Did it look like a cake?
You saw it?
Where?
Right there. The last one.
This one?
How they're all arranged. No, the problem. Go down to the last one. And then you see how they like stack up.
Oh. That does kind of look like a wedding cake. All right. Let's take a look. Are these parallelograms? Justify. Okay. Well, this one, look. Shh. This one, if these 2 angles are congruent, then you know that these 2 angles also have to be congruent. You see that? Okay. So therefore, this angle is congruent to this one, and that one's congruent to that one. So opposite angles are congruent. No, I'll get it. Thank you. Opposite angles are congruent.
Oh, should I teach you guys? Is it for me? I don't know. They always call me.
Matthew.
Oh!
What's your deal with study hall? Were you there?
No, I didn't go.
You didn't go.
I went to the baseball game.
Who was that? You're welcome.
You guys had that?
I forgot to tell them.
Should send an email.
Yeah,
Why did you guys get marks? Tardy up excuse or absent of excuse. Okay, these. Look, do these have to be parallelograms? Look, these two sides are congruent. These two sides are congruent. But that's not what I care about. If these were parallelograms, these two sides should be congruent, right? And these two sides should be congruent. That's not what it's showing me. So that doesn't have to be a parallelogram. You see that? It's not for sure. We don't know. Does that make sense?
Yes.
You guys got that?
Yeah.
Any questions?
No.
All right. That's it. You guys are done for the day. Very good. This will be on YouTube, so make sure that you look for it.